and different types of research designs, cross-sectional and quasi-experimental designs. But before we do that, let me go through my own research, and we'll go through it again so you can see what a research proposal looks like. Okay, so we talked about my research. My research was about resilience. The problem that I saw was that people were focusing on the negative things about my friends up on the Fort Belknap reservation, and they weren't seeing the positives about them, the fact that they were resilient. So I wanted to measure resilience in this population. So that's what I did, and I came up with a research proposal. My unit of analysis, of course, was resilience. My hypothesis was that when I measured the resilience of the individuals on the reservation, what we would find was that they had a high resilience score um, because they had survived the degradations of historical trauma. They had many of them had suffered from drug and alcohol abuse, and here they were being very successful. And one of the reasons that I wanted to do this had to do with the fact that if you have positive feelings about yourself, then you're less likely to try to commit suicide. And that's what I wanted to do. I wanted to focus on something positive rather than all the negatives that so many people focus on. So that was the problem in my unit of analysis. My unit of observation, of course, was a scale that I used that measured resilience. My hypothesis, I've already talked about my hypothesis. My null hypothesis was that they would not measure with a high resilience level. The dependent variable, in my case, was resilience. The independent variable, I wanted to find out what caused or what gave them their resilience. Was it their age? So I measured, I looked at the differences between the age groups. So age was a factor. Education, more education make you more resilient? Gender, does the fact that you're female make you more resilient than males? The level of trauma, the individuals that had gone through a lot of trauma, and I had a trauma scale that I used. Um, uh, did that was that a factor? And the last was level of cultural identity. Did a strong cultural identity make them more resilient? So those were my five factors. Those were my five independent variables. Ethically, I had a problem getting it approved by the tribal council, by the IRB at Fort Belknap. They put it together just for me. Aren't I the lucky one? Um, ethically, I had a problem, and what I did was I didn't measure the people on the reservation. I measured the American Indians that lived off the reservation, the ones that lived in the surrounding counties, but didn't live on the reservation because I couldn't get approval to run my surveys on the reservation, and that was a difficult decision to make, and I probably and it's questionable as to whether I actually should have done it. Anyway, okay, so my research design had I had three measurements and a information survey. My information survey gave me the information about their age, gender, and their amount of education. I also had a measurement to measure their resilience, a survey that measured their resilience. I had a survey that measured their level of ethnic identity. And my last one had to do with trauma, the amount of trauma that they had suffered through in their lives. Um, and what I did, I sent all four of those surveys out to all the people that I knew in the area, which wasn't that difficult because because the people that were the American Indians in that area had very distinctive names, and so it was fairly easy to go through the telephone book and find people who were had last names that were American Indian. Uh, that was my population. My population were the American Indians that lived off the reservation. That included the two tribes that were in the area. Um, the two tribes were the Gros Ventre and Assiniboine, also known as the Dakota and the White Clay people. And the White Clay people have since adopted their Indian name, Ani Nin. So those were the two tribes. But there was also um, there were reservations to the east, and there was a reservation to the west. The Chippewa Cree were at Rocky Boy, and to the east were the five Sioux tribes, and one of them was the Assiniboine. They're a Siouan tribe, and there were Crow to the south and Northern Cheyenne to the south. So it was possible that I was taking in all of these different, but I didn't ask them their tribal affiliation. I didn't want to separate them that way. So that's my population. That's my how I collected the data. I sent out surveys and they sent them back to me. As soon as they sent them back to me, I sent them a $10 bill and thanked them for taking the survey. What else happened? And that's it. That's it up to week 4. Let me talk about some more research. Let me talk about another type of research other than my own. One of the things that has been in the news lately is that the increase of loneliness in the United States. So I thought, well, why not come up with a research dealing with loneliness? So that is the problem is that since COVID-19, more people are reporting a feeling of loneliness. Um, if you watch any of the television shows where they're talking about mental health and whatnot, they will discuss loneliness, and that you should be aware of your loneliness if you're pulling back from people and not interacting as much as you did before. So that's the problem. Since COVID-19 that hit in 2020, people are reporting more greater feelings of loneliness. So my unit of analysis is loneliness, and my unit of observation is loneliness as measured by the 20-item UCLA loneliness scale. There is a loneliness scale. I can show it to you. I actually copied it. So, this should be here. I should have fixed this. Anyway, there's 20 questions. And you answer them either O, which is often, O is often, S is sometimes, R is rarely, and N is never. So you answer them in that manner. And then for an O, you get 4 points, or 3 points actually. For sometimes you get 2 points. For rarely you get 1 point, and never you get 0 points. So you add all this up, and if they have a high score, then that means that they're lonely. That's the UCLA loneliness scale. My hypothesis is that since the 2020-2022 pandemic, people are feeling more lonely. And of course, my null hypothesis would be the opposite of that. People aren't feeling any more lonely than they ever have. Now, how in the world am I going to measure this? Well, we'll get into that in just a second. Okay, so my dependent variable obviously is loneliness. My independent variable is, are people going out less? Are they communicating less? Are they spending more time alone? And are they are their future plans more isolated, being more isolated than they were planning before 2019? Is that right? Yeah, that's right. Okay. So as far as ethics go, I don't see any problem with this research. You always find it after you get started, though. So let's not worry about the ethics. How am I going to collect my data? I'm going to create two surveys. I've already got the UCLA loneliness scale, and I'm going to create two surveys. So this is how I'm going to run things. Well, I need to talk about my population. My population will be volunteers that I find, and I'm going to use my students at Fort Belknap as my as my as my population. So I'm going to get students to volunteer to take this thing. And the first thing I'm going to do is send them a survey that I've created. I haven't really fixed it up yet, but I'm going to create two surveys. One dealing with before 2020. I'll say in 2019, how often did you go out with friends in a week? How often did you text your friends a day? How often did you call your friends in a day? You know, things like that. So that will be one scale, one survey. And then I will send them that one. That's the first survey I'll send them. And then the second, and as soon as they send it back to me, I'll send them the second survey. And the second survey will be in 2023. Currently, how often do you go out with your friends in a week? How often do you text them? How often do you call them in a day? You know, that kind of stuff. Okay, so when they send me back the second survey, so the first one is prior to the pandemic, the second one is after the pandemic. Currently, you know, is there a difference? Well, that's what we're going to measure anyway. And then once they send that one back to me, I'm going to send them the UCLA loneliness scale, which you see in front of you right now. Okay, so that is my data collection and my population and my research design. Oh, so the data collection are the three surveys. And then we'll just add up the scores and see how they do. See if there's any difference between now and then, and see how they rank on the loneliness scale. Okay, so next week we'll talk about measurement errors, intervening variables, and sampling techniques. Week 6 we'll talk about the questions that we're going to ask. Weeks observations, what, where, and when. Week 8 we'll talk about coding categories, and week 9 we'll talk about data recording. So there you go. And this is the way I want you guys to work on your stuff, to think about your stuff, okay? Of course, you know, it took me months to figure out my research proposal for my dissertation. This one I just worked out about 20 minutes ago. I got to keep this piece of paper or we'll mess it up. Okay, so we'll talk about loneliness, my loneliness research, which I probably will never do, and my dissertation, which I did do. If I hope that helps you think about how you're going to do your own research proposal. And of course, you should have been doing this up to this point. In week 1, you needed your problem and to identify your unit of analysis. In week 2, there's a whole list of things that you needed to give me, identify. And actually, I haven't looked at this week because I had trouble with my recordings. So I'm a little bit behind grading. I'll jump right into that as soon as I finish all my recordings. I got a lot of recording to do. Today's Saturday. I need to have this stuff up by Monday, so I've got 2 more to go. Anyway, Okay, so the second week you should have had identified your unit of observation, your hypothesis, your null hypothesis, your dependent variable, and your independent variable. In week three, any ethical issues that you may have happen to have, and week four is telling me how you're going to do your research, research design, data collection, and population. And like some of you have discovered, I will help you with this if necessary. If you can't come up with something, I mean, this is the first time you've ever thought about doing research, and that's logical. I mean, sometimes you think too large, sometimes you think too small, but I will help you put all this stuff together. Okay, so that's my job. My job is to help you with your research proposal, and your job is to try to come up with this stuff on your own. If you can't, then it's my job to help you come up with a research proposal that is viable. And of course, probably you'll never do the research, just like I'll probably never do my research on loneliness, but that's okay. So let's go ahead and get into the lecture. We're going to talk about chapter 5 and chapter 6 today, and I'll get rid of this thing. Let's go ahead and save it. Okay, yeah. It's UCLA. You can see how slowly I type. There we go. Okay, there we go. Okay, so we're going to talk about design and structure research. Let's go ahead and get started. The research design is the blueprint of a study. Classic experimental design consists of two groups, an experimental group and a control group. As far as the loneliness research that I'm doing, as far as my dissertation was concerned, I didn't have a control group. I just had an experimental group. Both groups are equivalent, except that the experimental group is exposed to the independent variable and the control group is not. And of course, that's not the type of research that I'm doing. This is a classical experiment. Assignment to each group is by chance, of course. Rosenthal and Jacobson created an experiment with elementary students to see if they could create a self-fulfilling prophecy of success through expectation. They created a pseudo IQ test and gave it to a group of elementary students, and then randomly selected students who were bloomers and those who were not. Not war bloomers, but were bloomers. Okay. The experimental group were the 20% of students selected as bloomers, with all the other students as controls. The teachers were informed of the bloomers' potential. At the end of the year, all the students were retested. The intellectual ability of the students was the dependent variable. The 20% of students randomly selected as bloomers showed marked increase in IQ. The teachers' favorable expectations accounted for the gain. And that is about as sad a story as I can even give you. And the reason it's so sad is because all teachers should be teaching everybody as if they were bloomers. The classic research design consists of two comparable groups, an experimental group and a control group. Randomization ensures the comparability of these groups. The researchers take measures of the dependent variable, IQ, in the Pygmalion experiment. That's what they call this, Pygmalion. Pygmalion was a story written by George Bernard Shaw. It was a play written by George Bernard Shaw. My Fair Lady came out of Pygmalion. It's about the same story. I'm not sure why they changed the name. But the Pygmalion experiment, somebody with raw talent, and of course, the more you pay attention to them, the better they get. Once before the independent variable is introduced to the experimental group, known as the pretest. Once after the experimental group is exposed to the independent variable, known as the post-test. The classical experimental design is useful in the social sciences because it helps us understand the logic of all research designs. It allows for causal inferences because we can observe whether or not the independent variable caused changes in the dependent variable. Social scientists use the experiment less widely than natural scientists, primarily because its rigid structure often cannot be adapted to social science research, just like it doesn't fit in my loneliness research. Thus, social scientists frequently use designs that are weaker for drawing causal inferences, but are more appropriate to the type of problems that they examine. The demonstration of causality involves three distinct operations: covariation, non-spuriousness, and time order. It's a rather interesting phenomenon. Every time I press this lever, the postgraduate student breathes a sigh of relief. Covariation means that two or more phenomena vary together. In research, the notion of covariation is expressed through measures of relations, commonly referred to as correlations or associations. In order to infer that one phenomena causes another, a researcher must find evidence of a correlation between phenomena. We found this correlation in the data. Everyone take a razor. He's talking sales and shaved heads. Okay. The researcher must demonstrate that a covariation is non-spurious. A non-spurious relation is a relation between two variables that cannot be explained by a third variable. And of course, this is a spurious connection between sales and shaved heads. Okay. Researchers who establish that a relation is non-spurious have strong evidence that there is an inherent causal link between variables and that the observed covariation is not based on an accidental connection with some associated phenomena. And of course, this is classic. Do you think that all these film crews brought on global warming, or did global warming bring all these film crews? And of course, or if you're trying to say that the film crews caused global warming, that would be interesting. But if you're a penguin, maybe that's pretty close to being true. One last operation that must occur in causation inference is time order. The researcher must demonstrate that the assumed cause occurred first or the change happened prior to the assumed effect. This is not always easy, and the question of which came first, the chicken or the egg, that's exactly what time order has to do with. Which came first? Does the success of the student precede increased educational expectations of parents, or does increased educational expectations precede success of the student? Does depression precede substance abuse, or does substance abuse precede depression? Does achievement follow motivation, or does change in the level of motivation follow achievement? Classic research design consists of four components: comparison, manipulation, control, and generalization. The first three are necessary to establish that the independent and dependent variables are causally related. Comparison allows us to demonstrate covariation. Manipulation helps establish the time order of events. Control enables us to determine the observed covariation as non-spurious. Generalization, the fourth component, is the extent to which the findings can be applied to larger populations in different settings. And of course, one of the things that's going to happen with my loneliness research, which, like I said, will probably never happen, is that all I'm going to be proving with my loneliness research is that people on the reservation, or students on the reservation, are potentially more lonely than they were before. Can I generalize this to the entire population of the Navajo Nation? Potentially I can, maybe I can't. Can I say American Indians are feeling more lonely than the general population in the United States? Can I say that? And the answer is probably no. I would have to do this on more than one reservation, even to say that American Indians are more lonely than they were before. This whole concept of generalization, and sometimes we do make these generalized statements from very little research, and this is one of the problems with research, and this is what I'm talking about. This is what you need to be able to read. Just because this research where you use 1,200 students. Can you generalize this to the general population? And the answer is probably no. For one thing, most students are fairly young, and so all you can say is these young people, this is how they react. But let's say I did 15,000 students around the country. Now can I say that it's the same? I hit people in the Northeast, I hit people in the Southeast, I hit people in the Midwest, I hit people in the Northeast, West. I help people in the Southwest. Can I say it now? No, I still can't, because all I'm dealing with are students. I'm not really dealing with a cross-section of people. And we're going to talk about cross-sectional research in just a second. I think we are. Well, I think we are. Hypothesis: excessive television viewing by male adolescents leads to sexist views. Comparison: we can compare the views of teen males who watch excess TV with those who watch minimal TV. Manipulation: we can have one group of moderate TV watchers binge watch a sexual themed show and then measure their sexist ideas. Control requires that the researchers rule out other factors as rival explanations of the observed association between the variables under investigation. They must establish internal validity. Possible intervening variables: extrinsic factors for the TV research, religious affiliation, political affiliations, parental beliefs, peer beliefs, strict educational teaching, region of the country that we're dealing with. That's a lot of intervening variables, isn't it? Problem of internal validity: the requirement that the researcher rule out other factors as rival explanations of the observed association between the variables under investigation, extrinsic and intrinsic factors. This is the problem with internal validity. And the biggest problem is that a lot of researchers are just wanting to get their research done. They have this brilliant idea and they're not looking at the intervening variables. They're not thinking about the intervening variables. They want their own ideas to be specific. And this is one of the problems with studying one thing specifically, like psychology or like biology or physics. If you are a physicist, you think in a physicist's mindset. So you don't see variables that are outside the physics mindset. If you're a biologist, it's the same thing. If you're a biologist, you're looking at a worm and you're only thinking about what's happening to that worm. You're not thinking about the water. You're not thinking about the atmospheric pressure. You're not thinking about everything. And psychologists are kind of the same way. If this is all you know, if all that you know is psychology, are you thinking about intervening variables outside the realm of psychology? Could the barometric pressure be causing some problem? You know, are we thinking about, in my loneliness research, am I thinking about any potential intervening variable, like the fact that the cell phone service in 2019 was real crap, and now they've improved it in 2023, and now maybe that is an intervening variable and changing the amount of times that you're texting and calling your friends. That's a possibility. Maybe the place that you went in 2019 closed between now and 2023 because nobody was going out in 2023 since everybody was in lockdown. So maybe it closed. Now you got no place to go. Maybe that's why you're not going out with your friends as frequently as you were before. Maybe there's no place to go anymore. Okay, anyway, so we're talking about intervening variables. To establish internal validity, one must answer the question of whether changes in the independent variable cause the dependent variable to change. The effort to attain internal validity is the guiding force behind the design and implementation of a research project. And of course, that's your problem. Can you find other reasons for these things to happen? Extrinsic factors, biases called selection effects, can be introduced into research because of extrinsic factors that differentiate study participants. Selection effects are especially problematic in cases in which the individuals themselves decide whether to participate in an experiment. In other words, so what am I doing? I'm looking for volunteers to take my loneliness scale, right? Who are the people that are volunteering to do this? Are all these biology students? It's saying, yeah, sure, I'm going to take I'd love to do your research. Are all the fine arts people volunteering to do my loneliness scale? Or is it all psychology people and social workers and all of this stuff? Wow, wait a minute. Maybe that is a selection bias or a selection effect, as they say. In such cases, the investigator cannot tell whether the independent variable itself caused the observed differences between the experimental and control groups or whether other factors related to the selection procedures were responsible for the observed effects. Oh, no. Maybe there's something wrong with my research. Intrinsic factors include changes in the individuals or the units that occur during the study period, changes in the measuring instrument, reactive effect of the observation itself. The major intrinsic factors that might invalidate a causal interpretation: history, maturation, experimental mortality, instrumentation, regression artifact. Many of the intrinsic factors can interact with the extrinsic factors. Selection history interaction poses a threat when the experimental group and the control group are selected from different settings, so that each setting might affect their response to the treatment. Selection maturation interaction occurs when the experimental group and the control group mature at a different rate. And so who's maturing at a different rate? Well, boys and girls mature at a different rate. Maybe if you're asking elementary school kids a question, they'll answer it one way. But if you ask them the same question when they are in junior high, the girls will be more mature than the boys in the same class. That's the way it works. Girls mature faster than boys. If you ask them who their boyfriend is in elementary school, and of course it won't be the same idea, but they'll say somebody in the class. In junior high, they will tell you they would never date these boys. And by the time they get into high school, they're dating boys that are 2 or 3 years older than them. Wait a minute. Selection maturation. So that's a problem. That can potentially be a problem. Two methods of control to counteract the effect of extrinsic factors: matching controls for variables that are known to investigate to the investigator prior to the research operation, precision matching, and frequency distribution matching. And of course, that has to do with, are we talking about males and females? If we put too many females in one group and not enough females in the other group, is that going to skew my results? If we're talking about different races or ethnic groups, will that change the results? Say we're doing this in Tuba City and half of the population are Hopi and half the population are Navajo. If I put too many of one tribe in one group and not in the other, is that going to skew my results? Randomization helps to offset the effect of unforeseen factors. This is precision matching. Oh, we're talking about age groups here. And that's what I did. I did a cross-sectional study. So I had people from different age groups. Did I match them? Well, I didn't have a control and an experimental group. I just had an experimental group. Frequency distribution, yeah, here we are. We're trying to match our males and our females. Randomization is a process whereby participants are assigned to the experimental and control groups. Randomization cancels out the effect of any systematic error due to the extrinsic variables that may be associated with either the dependent variable, productivity, or the independent variable, participation in decision making. Randomization controls for numerous factors simultaneously, even when the researcher is unaware of what they are. Control groups are used to mitigate intrinsic factors. Control groups does not receive the experimental stimulus. The control and experimental groups should be selected by matching or random selection so they have similar characteristics. Both groups should also experience identical conditions during the study except for their differential exposure to the independent variable. Generalizability, external validity is the extent to which research findings can be generalized to natural setting and larger populations. The two main issues of external validity, representativeness of the sample, the reactive arrangements in the research procedure. And this is a question that might make you angry, but if I do research in Tuba City, can I generalize it to the entire Navajo Nation? Are the people in Tuba City the same as people in Crown Point? People in Crystal? Where else can I think of? Kienta? Can I do that? Is that true? Are all 275,000 people on Navajo Nation exactly? Are they similar? I guess that's a question I can ask. Four major design types: classical experiment. That's what we've been talking about. The quasi-experimental research, cross-sectional research. That's what I did. I did cross-sectional research, and I crossed it was the fact that I was using several different age groups. I think the oldest person that took my survey was 86, and the youngest person to take my survey was 18, because you had to be 18 in order to take the survey. The classic experimental design allows for pre-test, post-test, and control group experimental group comparisons. It permits the manipulation of the independent variable and thus the determination of the time sequence. Most significantly, by including randomized groups, it controls for most sources of internal validity. However, this design is generally weak on external validity and does not allow for generalizations to be made to non-tested populations, and has been said earlier, this is rarely used in social science. The pretest provides an assessment of the time sequence and a basis of comparison. The problem with a pretest is that it sensitizes the sample population to the measure and may seriously affect the post-test and thus the generalizability of the research. Now, one of the reasons why I am sending my population, my sample, my population is all the students at Dene College, and my sample is the individuals that volunteered to take my survey. So the reason that I'm sending them my surveys separately is so that potentially they will forget. By the time they take the second survey, they've forgotten what they're not thinking in the same line as they would be if I gave them all the surveys at the same time. That might what's the word I'm looking for? Prejudice their idea by looking at, oh, this is me in 2019, this is me in 2023, and he's giving me the loneliness scale. So he wants me to be lonely. That I don't want them to think in that way. I don't want them to know about the loneliness, to look at the loneliness scale. If you could do it backwards, if you did it backwards, then potentially that would really skew my results. So what I'm going to do is give them the 2019 scale. I'm going to still call it the loneliness survey, but they really don't understand what I'm looking for until they get to the loneliness scale. And that's the last survey they'll be taking. So potentially, if there's a week between the time they take my first survey and the second survey, they will not really be thinking in that a lot of stuff has happened in that whole week. So they won't be thinking in that direction. That's what I'm hoping anyway. And so by the time I send them the loneliness scale 3 weeks later, they won't be thinking, wow, this is what he's trying to get me to say. So the pretest provides an assessment of the time sequence and the basis of comparison. The problem with the pretest is that it sensitizes the sample population to the measure and may seriously affect the post-test and thus the generalizability of the research. And that's what I'm trying not to sensitize my population as little as possible. And that's one of the reasons why I'm going to wait until I get the first survey back before I send them the second survey. Because gives me less of a chance of sensitizing that individual to what I'm trying to do. The Solomon 4-group design contains the same features as the classic design, but adds an additional set of control and experimental groups that are not pre-tested. Now, the probability of you using a Solomon 4-group design in social science is not that great. You just need to understand this. I don't really expect you to use these designs or to even talk about these designs. All I want you to do is be aware of them. That's why we're talking about, the pre-test, post-test. You probably aren't going to do that. Even the classic experimental design, the probability of you using that design isn't very good, but it teaches you what research is all about or how research works so that you can think about doing your research in a scientific manner. That's what we're trying to teach you right now. You don't really need to memorize this stuff because this stuff is something that you'll never need. But you need to understand it so that you understand the scientific method. I hope that's as clear as mud. Therefore, the reactive effect of testing can be measured directly by comparing the two experimental groups and the two control groups, and that's what they've done. They've created two controls and two experimental groups, and now they're going to compare the two types of groups. Post-test only control group design is a variation of both the classic design and the Solomon design. Post-test only control group design omits pre-tested groups altogether. The post-test only control group design groups are identical to the last two groups of the Solomon 4-group design, which are not pre-tested. Individuals are randomly assigned to either the experimental or the control group and are measured during or after the introduction of the independent variable. Post-test only control group design controls for all intrinsic sources of invalidity. Now, there's a reason why this is rarely used, and the reason is because we're not really introducing the independent variable. The independent variables have to do with, in my research anyway, and probably in your research, is a constant. Going out less frequently, you can't tell somebody, I want you to go out more than you did before. I want you to communicate more with your friends. I want you to spend more time alone. You're one of my controls, so you spend more time alone. And now that you made plans for the future, Okay, anyway, you see what I'm talking about. This is a research that would be done in a laboratory where you could control all the variables. And that's okay, because when we're talking about the scientific design, primarily we're talking about the hard sciences. We're talking about physics, we're talking about biology, we're talking about all the hard sciences. Social sciences are soft sciences, and that's okay, because in biology and physics, things are constant. There are constants that they have to identify. In social sciences, there are no constants. Nothing is constant. Life is the only constant, I guess. But everything else changes over time. It evolves. We are a continually evolving species. And that's what we're trying to figure out. We're trying to figure out how we can, how change can make us better, trying to make us better rather than worse. So as you know, when you're 5 years old, you're fine. You're going to school. Everybody's happy. You're in junior high, and somebody offers you a cigarette. You don't take it. You're still fine. And then when you get into high school, somebody talks you into drinking your first beer, and then it's Katie bar the door. You're chugging a 6-pack every night. Okay, so as psychologists, what we're trying to figure out is how can we stop that high school effect of chugging beers, a 6-pack every night. But then again, you've got other kids that aren't doing any drugs. You can see what I'm talking about. I'm talking about the evolution of humanity here, and how people change, and how we need to control the negatives and eliminate the negatives and support the positives. But we have to identify what's negative and what's positive. Factorial design examines the effect of more than one independent variable simultaneously. If each independent variable has only two possible values, dichotomous variables, four experimental groups will be needed to study all combinations of these two variables. Like I said, this has to do with the Solomon effect, or the Solomon design. Don't worry about this stuff because you'll never be using this stuff. Factorial design, looking at company size and decentralization against morale. Size and decentralization are our independent variables, and morale is the dependent variable. The four possible combinations are large size and high decentralization, small size and high decentralization, large size and low decentralization, small size and low decentralization. I have a former student who studied industrial organizational psychology. And a lot of times, these types of designs are things that he would be looking at. And this would be a possibility as far as he was concerned, because he would be looking at how to increase productivity in a factory situation. Yes, this fits what he's talking about. But I'm talking about loneliness. You guys are talking about murdered and missing women. We're talking about a lot of different things that you can't do these kinds of designs for. So the reason we're talking about this is because this is a possibility, and this is more scientific than the type of research that we tend to do in social science. Factorial designs, and you need to understand it in order to understand the scientific method. The factorial designs, the chief advantage of factorial designs is that they may considerably broaden the range of generalizability. The researcher is able to infer that the effect occurs similarly across several levels of the variables, or that the effect is different at different levels, or of one or another of these variables. Another advantage is that it allows assessment of how two or more independent variables interact. Okay, but we don't have the luxury of manipulating our variables, do we? Because that's not how human research works. Okay, so that was a lot of information about scientific design. Most of that stuff, don't worry about it if it doesn't make a lot of sense. When you start studying or looking at research, reading some research about PCP or whatever, or some drug. Usually, when they do research with drugs, of course, that is a scientific design. So they will have a control. They will have an experimental group. One group gets the drug, and the other group gets the placebo. Other than that, just don't worry about it. This is not something that you need to worry about. However, Chapter 6 is about cross-sectional and quasi-experimental designs, and that's what we do mostly in social sciences. The last chapter was about a type of research that is rarely done in social sciences. This chapter is about research that is very frequently done in social sciences. Stimulus-response relationships are well suited for experimental investigation. Stimulus-response relationships are characterized by an independent variable that can be manipulated by the researcher. The researcher might induce stress or expose research participants to a political candidate's advertising campaign. The dependent variable would then be a direct response to the independent variable. It could be a psychological reaction to stress or a strong emotion or opinion about the political advertising campaign. In other words, what we're doing is we're showing you a stimulus and we want to know how you respond. Does it make you angry? Does it make you want to go out and shoot somebody? Does it make you want to vote for the candidate of their choice? Property disposition relationship is a relationship between some characteristic or quality of a person, their property, and corresponding attitude or inclination, disposition. An example would be socioeconomic class and political tolerance. Another example would be the relation between race and prejudice. And this is really kind of interesting because you may be able to identify with this cartoon. How do we categorize these people? This is a mixed race person. This is somebody who is mixed race. Okay, so the government bureaucrats are trying to figure out how to categorize them as far as the census is concerned. The politicians are trying to figure out which voting block do they fit into so that they can get their vote. And the ethnic interest group wants to know, what do we call them? I think I talked about the Métis. Métis is an old term for mixed race people. Primarily, they were the offspring of French trappers and American Indian women up in Canada, and it was obviously up in Canada. Because in the United States, we really don't deal with this, with the fact that there is a mixed race population of American Indians. But in Canada, they do, and there is a specific group of individuals who refer to themselves as Métis. And if you go up into Montana and North Dakota, then you run into people that will tell you, what is your tribe? They'll say, well, I'm Métis. And it's really kind of interesting because I've been to a Métis powwow, and they don't dress like most American Indians at a powwow. They wear jeans and moccasins and fringed shirts. It's really kind of interesting because the powwow regalia of most of the tribes in Montana is fairly distinctive, and a lot of deer skins and whatnot. But the Métis don't wear that kind of stuff. And they don't wear anything on their heads, or if they do, it's just a hat. It's really kind of fascinating. Really kind of fascinating. Anyway, well, we won't get into that. I guess we already did, didn't we? Anyway, so you could probably identify with this. The government wants one thing. The politicians want to figure out how in the world they can get you to vote for them, and the ethnic interest groups are trying to trying to pin people down at the same time. Stimulus response relationships differ from property disposition relationships in 4 ways. Time interval. In a stimulus response relationship, the interval between the introduction of the independent variable and the response to it is relatively short. In a property disposition relationship, the time interval can extend over a long period of time. Degree of specificity. A stimulus is usually easy to isolate and identify, and its effect can be delineated concretely. A property such as a social class is more general and incorporates various factors: prestige, occupation, education, and all exert their relative influence. The nature of comparison groups. When studying a stimulus response relationship, a researcher can compare two similar groups, one that has been exposed to the stimulus and one that has not, or the same group, both before and after exposure to the stimulus. When studying a property disposition relationship, a before-after comparison is impossible, especially with properties do not change, such as gender and race. You certainly can't change somebody's race, and you can't change their gender. You can change their social status, I guess, and people do change their social status over time. But there's nothing there is now. You can change your gender, I guess. But I'm not exactly sure if you could change your race. And the answer to that is, yeah, race. The whole concept of race changes over time. Like I said, we are studying human evolution, and that evolution is really kind of curious. Let me give you a quick example. Back at the turn of the 20th century, there were groups coming in from Eastern Europe, and they weren't considered white. They weren't considered white, and white at that time was defined as either German, Northern European, French, or English, or Irish. I guess Irish too. They referred to Irish as Black Irish, meaning that they were a level below all these other groups. So they started getting people coming in from Eastern Europe. They started getting Italians and Greeks and Hungarians, people from the old Austrian Empire, and these individuals were not considered white. They were considered a lower group, but they were considered white. Now, in time, of course, the whole concept of whiteness has changed, as bizarre as that is. And that's one of the reasons why, there's so much confusion about our history, because our concepts of who people are has changed over time. So when we look at something, if we read something that happened in 1860, and then read about the same thing that happened in 1910, and then the same thing that happened in 1970, it all may be different. The words that people use may be completely different, because our concepts of who people are has changed over time. As weird as that sounds. So race has actually changed over time. The whole idea of who is white has changed over time. Not important. The time sequence of events with stimulus response relationships, the direction of causation is relatively clear, especially when the research design allows a researcher to make before and after comparisons. When properties are permanent, such as race and gender, researchers establish causal direction based on the fact that these can only be determining factors, not determined effects. Because of the difficulties with property disposition, relationships social scientists cannot apply comparison, manipulation, and control in the pure experimental sense. Yet social scientists try to approximate the experimental model by employing specialized data analysis techniques that compensate for the limitations inherent in studying property disposition relationships. Okay, and this is true. My son is a mathematician, and About 3 summers ago, when he moved from, where did he move from? Florida to North Carolina. Um, he was going to teach statistics at Diné College. And so, that was the deal. I gave him the textbook, and he's got a master's degree in mathematics. I mean, he can do statistics without even thinking. However, when I gave him the textbook, he said a lot of this doesn't make any sense. And the reason it didn't make any sense is because when he was doing statistics, it was pure mathematics. When social scientists do statistics, they use special techniques in order to make things that aren't numbers into numbers. I had a student at Ashford who was doing his thesis, and he was a mathematician, and he took his results to the math department, and he wanted this guy to help him with his statistics. And what happened was the guy didn't understand. He didn't understand uh, that you can quantify certain ideas. You have to quantify these things, and it didn't make any sense to him because it wasn't pure mathematics. It wasn't pure, and he didn't understand it. So this is one of the reasons why statistics are interesting as far as social scientists are concerned. And this statement is true. Social scientists try to approximate the experimental model by employing specialized data analysis, regression analysis, for example, that compensate for limitations inherent in studying property disposition relationships. How do you quantify depression? But we do. We quantify depression. How in the world do you quantify resilience? How would you quantify loneliness? Well, you can. You can do it because UCLA has a scale with that give you numbers, and that's the way. It's a statistical manipulation as it is. A cross-sectional design looks at different groups. Okay, and this is a point of fact, and this is one of the reasons why when you start doing statistics, what you need to remember is that some of these statistical techniques that you're going to be using uh, aren't especially mathematical. They're more uh, trying to determine understanding rather than mathematics. It isn't pure mathematics. So don't show it to a mathematician. They will have a heart attack and die. A cross-sectional design looks at different groups at the same time to determine if there is a difference in their responses. The groups can be age groups, elementary students at the same time as middle school students and high school students, economic groups, poor people and wealthy people, racial groups, whites, blacks, Hispanics, natives, and Asians. That's a cross-sectional design. We're looking at different groups. But it all depends on what your definition is. So when I'm talking about loneliness, potentially I can do my loneliness scale looking at different age groups if I can find students of different age groups. Cross-sectional designs are one of the most widely used designs in the social sciences and are frequently employed in survey research. In most cases, researchers in cross-sectional studies are simply trying to describe relationships between variables. Hence, cross-sectional studies are usually referred to as correlational studies. Exit polling done during the 2012 presidential race between Barack Obama and Mitt Romney looked at the impact of race ethnicity on the candidate of choice. Race ethnicity is not a variable that can be manipulated, nor does it lend itself to before and after comparisons. But this is what they found out. Now, the vast majority of people in the United States, in 2012 is probably 70% of the population was white. So these are the numbers that are really, really important. This represented about 12% of the population. This represented about 12% of the population. So what we're looking at is this number is huge. This number, not so much. It's only 12% of the population. And of course, that's what popped him over the line. These votes will always be about the same, Democrats and Republicans. Quasi-experimental designs allow researchers to select random samples from the population, but do not require the random assignment of individual cases to the comparison groups. Quasi-experimental designs are weaker on internal validity than experimental designs, so researchers must depend on data analysis techniques for accuracy. Quasi-experimental designs are superior to cross-sectional designs because they usually involve the study of more than one sample, often over an extended period of time. The least elaborate design for contrasted group design is one in which individuals or other units of analysis are regarded as members of categoric groups. Members share one or more attributes that assign them to an identifiable category. In the non-equivalent control group design, researchers compared two or more intact groups before and after the introduction of the treatment variable. Non-equivalent control group designs is a more elaborate design for contrasted groups. A college looking at remedial English classes compared fall with spring semester remedial classes. The dependent variable was the success of the students had in the freshman English class after taking the remedial classes. The results show that the students who took the remedial English classes did better in the freshman English classes than the students who did not take the remedial classes. Planned variation designs expose individuals to stimuli that have been systematically varied in order to assess their causal effects. The Head Start planned variation is an example of this design. Overall, both the sponsors programs and the regular Head Start programs tended to accelerate certain kinds of academic performance. Pooling the 11 specific sponsored sets of classrooms and comparing them with the regular non-sponsored Head Start classrooms showed no large differences. When the sponsored set of classrooms were compared among themselves, some differences in performance emerged in several of the cognitive tests the children were given. In other words, what they were talking about is there is a government Head Start program, and then they had Head Start programs that were sponsored by different companies and taught in different ways. Now, when they looked at, and of course, these kids are what, 4 and 5 years old, so what are we getting here? But what we've discovered is that the kids who go into Head Start have an advantage over the kids who don't have Head Start. Now, one of the interesting things about Head Start, when they started Head Start, it was for disadvantaged students. It was for poorer kids. And so they started the Head Start program, and by golly, what they discovered was these kids were ahead of the kids that had all the money, the advantaged kids, and they didn't like the advantaged parents didn't like that. So the advantaged parents wanted Head Start for everybody, and then they did that, and then all of a sudden they decided, wait a minute, if we've got all this cash, so why don't we just do our own Head Start? And that they did that as well, and that's what they were looking at in the HSPV program. And what they discovered was the emphasis. If the emphasis was on writing, that's how the kids showed promise. If it was in math, of course, that was the area that was more important, that became better. Panels are a design in which the same sample is examined at 2 or more time intervals. Panels allow researchers to approximate the before and after condition of experimental designs more closely by studying a group at 2 or more points in time. The main advantage to a panel is that it enables researchers to determine the direction of causation. Problems with panels: obtaining an initial representative sample of respondents who are willing to be interviewed at set intervals over an extended period, as well as maintaining those participants throughout the study. Repeatedly interviewing the same group may sensitize the respondents to give a given answer, a set of answers called panel conditioning. Time series designs are used in cases where no comparison or control group is available for assessing cause and effect relations. Time series designs are studies in which pretest and post-test measures are available on a number of occasions before and after the activation of an independent variable, where an investigator attempts to obtain at least 3 sets of measures before and 3 sets after the introduction of the independent variable. Extended time series design controls for maturation, where there is a data gathered over a number of years prior to the measured change. A classic extended time series design was a study of traffic deaths in Connecticut in the 1950s. Traffic deaths were always studied, and the demographers discovered a peak in 1955. But the number of deaths, though they fluctuated, were always high. In 1955, there was a crackdown on speeders, and in 1956 showed a sharp decline. However, researchers discovered that traffic deaths fluctuated wildly, and statistically it could not be shown that the crackdown caused the precipitous decline in 1956. The steady decline after 1956, however, demonstrated that crackdown's effectiveness. Da-da-da-da-da. Okay, and there you go. So maybe it actually worked. Control series designs attempt to control aspects of history, maturation, and test-retest effects by comparing the results to a non-comparison group. In Connecticut traffic death study, researchers compared Connecticut's death rate to that of neighboring states and discovered a steady decline after the crackdown that wasn't evident in neighboring states who had no crackdown. And there you go. And this is how they determined that stopping speeders actually changed the number of traffic deaths by comparing Connecticut to neighboring states that didn't have a speed crackdown. In the initial design in the Salk field studies, the idea was to give the vaccine only to second graders whose parents volunteered them for study, and not to give it to first and third graders who comprised the comparison group. Some state public health officials recommended a controlled field experiment that randomized the distribution of vaccine among volunteers from all grade groups. In the end, some states applied original design and some applied randomized controlled design. And you can imagine how this might have pissed off parents, especially after they discovered that it worked. And how would you like being in one of the groups that had a placebo instead of the polio vaccine, and your kid came down with polio? You'd want to punch somebody. Now, weirdly enough, all this was done. Salk was he on the East Coast? Anyway, they did most of this research in the Midwest, where there were a lot of kids. Anyway, they did a lot of research in the Midwest, and one bit of research that if you were around in the 1950s and 1960s and you brushed your teeth and watched television, then you probably discovered that Crest did a study with fluoride. They had fluoride and it tasted terrible. Crest toothpaste used to taste so bad. Anyway, they did a study with fluoride to determine if it stopped cavities. And one of the schools that they used was my school. And unfortunately, most of the kids in my school got the placebo, and so our teeth were pretty bad, even though we were using Crest. It didn't have any fluoride in it, and that's how they determined that Crest actually worked, by using half the kids as placebos. And unfortunately, a lot of the kids at my school were given the placebo Crest. Pre-experimental designs may be the only available technique for many policy questions when it is difficult to implement an experimental or quasi-experimental design. Pre-experimental designs have no control group. One example of a pre-experimental design is the one-shot case study, which involves an observation of a single group or event at a single point in time, usually at a time of change. One-shot case study limitations include no control over extrinsic and intrinsic factors. It does not allow for before, after, or control group, experimental group comparison. It cannot be used for testing causal relations. Pre-experiments are the weakest research design because most of the sources of internal and external validity are not controlled for. The risk of error in drawing causal inferences from pre-experimental designs is extremely high. They are useful primarily as a basis for pre-testing some research hypotheses and for exploratory research. And comparison of designs. There you go. And that is the end of the lecture. Okay, so we're talking about research designs, and I hope you can come up with a design for your experiment. And if you can't, between the two of us, I'm sure we can figure it out. So I'll see you next week.